Hello, geometry students. Mr. Zacek back and better than ever with you here in Unit 4, Lesson 6. We're going to talk about proving right triangles congruent and try to answer a question of how we can do that. So to begin with, we're going to look at some vocabulary related to a right triangle. And a right triangle is a triangle that has one right angle. Okay, so as you can see here, this is our definition of a right triangle. And the sides that form the right angle are called legs. As you see on the diagram here, we've got one leg and the other leg. It doesn't matter. They're both called legs. And then the side that is opposite the right angle, and when we say opposite, like here's the right angle, here's the other side, it's the hypotenuse. And the hypotenuse is the longest side of the triangle. Okay, so there's a theorem that we've talked about before. Well, it's not really a theorem, but a problem that we've had is if we have two sides and a non-included angle of one triangle are congruent to two sides and a non-included angle of another triangle, then we can't prove that those two things are congruent. All right, we call this the donkey theorem. And the reason is because there's an angle and then two sides. So angle, side, side, or we can think of that as side, side angle. All right, well, that doesn't work, and this picture shows that if we notice the two triangles are not congruent, this is not a valid method. However, okay, so this and this don't work. However, this method works in the special case of a right triangle. Okay, so notice special case is that we have a right triangle where the right angles are the non-included angles. And the theorem that we have, this is going to be our fifth reason for proving triangles congruent, is hypotenuse leg theorem. So if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So if you look at the diagram, PQR and triangle XYZ are right triangles, and then PR, okay, this right here represents the hypotenuses. Okay, and then over here we have the corresponding legs. Then we conclude the triangles are congruent. Okay, so one of the big things which is starred down here is that we must state that the triangles are right triangles in order to use the hypotenuse leg theorem. So that has to show up as a statement in the proof. And so we'll do some examples here in a little bit, and I'll show you how we're going to do that. So this is a proof of the hypotenuse leg theorem, and this looks like it got cut off in printing, but it's here. And so if we have XR congruent to XZ, and we have this by the reflexive property, and we have perpendicular lines, okay, we have 1 and 2, so here and here. Triangle or angle, they're right angles, perpendicular lines form right angles, and they're congruent to each other. All right angles are congruent. Well, in addition, this big triangle, this large triangle from our last lesson, this is an isosceles triangle. And what did we say is if two sides of a triangle are congruent, that's XR and XC, then the angles opposite those sides are also congruent. So this angle would be congruent to that angle. All right, and therefore the triangles are congruent, so by angle, angle, side. All right, what is that doing here? Well, what we're doing is we're proving that hypotenuse leg is a valid reason. So we can actually do this with a different approach now because we've proven it. And I'm going to show you some examples on how to do that here. Okay, so we're given that PS is perpendicular to RQ, and so we know that that unlocks us having right angles. We're given that PR is congruent to PQ, and we're given from just the diagram that this is here. Okay, so here's kind of the thought process. Okay, notice that this is side-side angle. However, we have a right triangles, two right triangles. So therefore, we can use hypotenuse leg. All right, so that's the thought process. Side-side angle, oop, that doesn't work. However, this is a right triangle, so we can use hypotenuse leg. So let me show you how we'll do that. So PS is perpendicular to RQ, and PR is congruent to PQ. All right, that is given. Okay, so what we're going to say next is angle 1 and angle 2 are right angles. If two lines are perpendicular, then they form right angles. If two lines are perpendicular, then they form right angles. If two lines are perpendicular, then they form right angles. Now, this is why we've always done the right angles in 2 steps instead of 1 step, and it's for this scenario here. Now, I could say angle 1 and angle 2 are congruent, all right angles are congruent, but I don't need that. What I need is, I need to say that triangle PRS and triangle PQS are right triangles. And the reason is, if a triangle has a right angle, then it is a right triangle. A right triangle. See, in order to use hypotenuse leg, we have to say that they're right triangles. Okay? So we've said that they're right triangles. Now the other piece we need is the legs, which is PS congruent to PS by the reflexive property. Okay, and so now we can say that triangle PRS is congruent to triangle PQS, and the reason is because hypotenuse leg is congruent to hypotenuse leg. All right, so there's still 3 things. All the other reasons that we have require 3 statements, and this one is no different in that it requires 3 statements. The difference is one of those statements is that they have to be a right triangle. Okay, so this is a new method that we have in these cases. All right, let's try another one. So we're trying to prove the triangle is congruent, and we're given PB is perpendicular to AB. I'm going to call that angle 1. And then PD is perpendicular to AD. I'm going to call that angle 2. Okay, and then we're given that AB is congruent to AD. And then by the reflexive property, we have this here. So the way that we want to see it is, you know, kind of thought process. Side-side angle, oh, can't do that. Special case, right triangles, okay, yes. So therefore, we can do hypotenuse leg. All right, so let's go ahead and do it. All right, PB, perpendicular to AB, and PD, perpendicular to AD. Let's just go ahead and do the right triangle piece first. All right, given. I'll bring the other given in later. Just like to do that to give you some variety. So angle 1, angle 2 are right angles. If 2 lines are perpendicular, then they form right angles. If 2 lines are perpendicular, then they form right angles. sometimes in your like an answer key from the book, it'll just say that definition of right angles. All right, now here's the new piece. So therefore, triangle APB, triangle ADP are right triangles. So, and it's this, if a triangle has a right angle, then it is a right triangle. So that's we've said their right triangle piece. Now let's do the hypotenuse, which is AB congruent to AD, and that was given to us. All right, and then we get the legs because of the reflexive property. So AP congruent to AP, that is reflexive. All right, and then, so now we've got that going on, and therefore, number 6, triangle ABP is congruent to triangle ADP, and the reason for this is hypotenuse leg congruent to hypotenuse leg. All right, let's see here. Okay, one more. I think one more. Is there more than that? There, yeah. Then we'll take a break and go on. We'll split this video up here for this lesson. Okay, so we've got CD is congruent to EA, and we've got that AD is the perpendicular bisector of CE. Okay, so AD is the perpendicular bisector. That means this angle and this angle, not only are they vertical angles, but they're also right angles. AD is cuts CE, so CE is the one that's going to form these. All right, so again, thought process here, we've got side-side angle, okay, so therefore hypotenuse leg. All right, and then it says prove that angle E is congruent to angle C. Well, that would just be corresponding parts of congruent triangles are congruent. Okay, so let's go ahead and execute this proof. So CD is congruent to EA, and AD is perpendicular bisector of CE. Okay, given. All right, well, we've already got the hypotenuses. Now we've got to get the other parts, the right angle piece. So angle 1 and angle 2 are right angles. Okay, if two lines are perpendicular, then they form right angles. If two lines are perpendicular, then they form right angles. All right, so that gets us in the hypotenuse leg case to say the angle, no, excuse me, I gotta say the triangles are right triangles. So triangle, let's say ABE, and let's call the other one, if we call it ABE, let's just get them lined up. It would be DBC are right triangles. Okay, if a triangle has a right angle, then it is a right triangle. So we've said that it's a right triangle. We've got the hypotenuse congruent to the hypotenuse. We've got to get the other leg, and it's part of this reason that AB is a bisector of CE. So we can say that CB is congruent to BE, and this is our segment bisector reason. If a segment bisects a segment, and then it divides it into two congruent segments. So then it divides it into two congruent segments. All right, so we've got our hypotenuse is congruent. Okay, this is our kind of H congruent to H. This is our leg congruent to a leg. We've said that they're right triangles. Okay, that's kind of check mark 3. And then we can say triangle ABE is congruent to triangle DBC. And the reason is hypotenuse leg congruent to hypotenuse leg. All right, now that the triangles are congruent, all of their corresponding parts are congruent. So angle E is congruent to angle C, angle E congruent to angle C, and its corresponding parts of congruent triangles are congruent. Hey! All right, so we're mixing some things together, and now we have our fifth reason for proving triangles congruent, the special case called hypotenuse leg. All right, next, the second part of this video will be more examples, but we'll break this up into two. So good luck.